What? It's Thursday? It's Thursday again? And we're live and on the air? Huzzah! You know what? I am really washed out. Let me see if this improves. Let's try that. It either works or it doesn't work. I don't know. Beg your pardon. Hey, well, anyways, welcome back to, let's call it sunny Houston. And you have found your way to ADRAMADA. Another Dave Rush Ask Me Anything digital alchemy, and I am the aforementioned Dave Rush. And come for the shirt. Stay for the news and the project. This show is devoted to collecting and disseminating information on technology and its uses, and it's wide-ranging, and it's a lot of fun. And today, if you are not watching this live, we recorded this on Thursday, February 13th at 7 p.m. Central Time, which is when we always try to do it. I have another set of responsibilities, and sometimes they chew up my evenings, and we have to move it to Friday. But today, we are on schedule and on time. And next week, we are Friday next week for certain. I'm coming to you live from Houston, Texas. The weather has settled back into regular South Texas, East Texas norms. It's a high of 60 Fahrenheit in the day and 40 at night, and that's normal for us. The Super Bowl is over this past weekend. I hope your team won. I just didn't have a dog in this hunt. There are things that I liked. There are things I didn't like. I watched the game to the end. But as a game, as football goes, it was just disappointing. As commercials go, disappointing. Some commercials had moments that, okay, that's all right. But it was just not a pretty picture for football. And I love football. So, here we are. We are into our third year of ADRAMADA. I think this starts officially our first show of the third year. We've got a Discord server. It's just a generic tech server. We have a lot of fun. We have a lot of great people on there. Conversations go everywhere. They're tech, they're non-tech. And I have posted the link for it at the beginning of the show chat. So dive into that. Likewise, there's email addresses if you ever want to communicate with me in other ways. My X account's on there. My Mastodon account is on there. Okay. Enough commercials. We have another commercial coming later. So last week, we began a multi-part series. It's going to run 4 parts because next week is a long topic, and I just can't squish it into one 30-minute chunk of show. So we're going to do it in 2 chunks of shows. But we started a series on subnetting. When you get done with these 4 half-hour presentations, 2 hours out of your life, you will be able to subnet. You will understand subnetting. You will apply subnetting. And not the most advanced stuff, but you'll be able to do things that people do every day in complex networks, in network operations centers. So what we did last week is we laid down the first of 2 foundations. And these foundations are, you don't really need to have much of a background to start where we did. We looked at binary numbers and decimal numbers, and I showed you how to convert back and forth without a calculator, which is a really important skill if you are pursuing, let's say, some kind of networking certification from 1 or 2 of the big certification organizations out there. At least one of them doesn't give you a calculator. They give you a piece of paper, or a whiteboard, a physical whiteboard, or an electronic whiteboard in their testing software, and showed you what you need to do in order to do the inevitable calculating that you're going to have to do. This week, we extend on that by saying, okay, now we have a basic understanding of binary numbering systems, and we talked about the fact that IP addresses have 32 bits in their number. So what we're going to do is we're going to move that into IP addresses. Where do IP addresses come from? not why are they 32 bits, but what can we do with the 32 bits, and how are they organized, and how are they assigned to people who need blocks of IP addresses. It's going to be a lot of fun, and it's not difficult. It's easy. Anybody can do this. Yes, sir. I'll be there in a second. Hey, upcoming this weekend for many Americans, it is a 3-day weekend. Monday, February 17 is President's Day here in the U.S. Real Americans will still work, but government and banking employees get a paid day off. Why is that? Joey Quetzel's here on a Thursday. Yahoo! So upcoming shows. We're doing Classful IP addressing today. Next week, we start into the real meat of subnetting. So we'll call it subnetting or CIDR, classless interdomain routing. And we'll see what all that entails. That's February 21st, I believe, and then Feb 28th, last day of the month. It's a 28-day month. We will complete anything that I left out or needs to be clarified, and then we'll do some practice. The following week, March 6th, we have a special guest, Maxine Hayes, a woman who I followed, with whom I've communicated some, not a lot. I'm not going to rate our relationship as friendship or anything like that, but I certainly know about her. She may know a little bit about me. We both have a strong affinity for Rocky Linux, and she wants to talk about Plan 9 Linux/Unix. I want her to talk about that. She's got some expertise in that area. She wrote a marvelous article that I found really intriguing, and asked her if she'd like to come on the show and talk about it. And she was very happy and gracious to accept that offer. So what do we got going on? Let's see who's here. Zooming up. Patricia Grace was in and out with a sorry, I'm going to miss it, which I think becomes, therefore, Jason, the answer to our question. There are two people who wanted to participate in the show and an after show, but both of them have commitments that cuts our numbers a lot for a post-show hangout, so I'm not going to hang out this week. Next week or the week after, definitely got the time to pull that off. And who knows if we could maybe invite Maxine, there we go, to join us on an after hangout if she's got the time and the inclination. So that would be cool. Who else be here? Tullowit, of course. Hey, Tullowit, you sometimes you surprise me. I did the show announcement fairly early this morning, and you weren't the first one to jump on. But here you were, half an hour before show, wishing us all a lovely afternoon. Jason Helms is here doing what's up. Joey Quetzel, who usually turns up on Friday shows, thanks for making it on a Thursday show. Oh, who the heck just joined? We got a regular. I'm brain farting on his avatar name. I'll look as we go here. We got things to do here. Jason says, in the world of someone we all know, get a piece of paper. I said it again, piece of paper. Okay, I love that you said that, because I got a call from that person yesterday, and I'm going over to his house tomorrow morning, and I don't think I've given anything away here because I really don't have anything to give away, but he has torn down his YouTube studio quite some time ago, and he's got the itch again. I don't know what he wants to do on YouTube, but he's invited me to come over and help rebuild and get his studio restarted again. So I will be over there tomorrow morning having fun, and who knows what tidbits will come out of him. Yes, counting backwards like a weirdo, aka CIDR. Yeah, sure, you betcha, huh? America, fight for the rights of every man. I'm a real American. Browsing points, if you know what that's from. Brownie points. I see where you're going with that. Understand, want to confirm, yep. I did a very early one. It disappeared so early that it vanished. Okay. I always thought they stayed up for about 24 hours. I do not know. Man, that is good juice. It's not iced tea. It's not seasoned here. There will be a wireless drinks. After show. I'm loving that. Do me a favor. Tell them I said hello. I certainly will. I will pass along greetings from all of you. I'm sure you would express them. You think so, huh, Tullowit? He has his moments. And he has moments of the opposite. You know, I checked with it. It turns out he's human. He gets up days, he gets down days just like the rest of us. And I love hanging with him, whatever condition he's in. All right, let's... Oh, this... No, not that. This. Come here, you. Oh, that's a funky place. So let's devote a minute to our lovely sponsor, the nice folks at Dartnode. Dartnode is a NOC. They're a network operations center. They will lease or sell you various computer products that are online at a data center. So you can, so excited. I can't wait to get to the end of this thing because they've got a special just for the viewers of this program. But I'll get into that. Anyways, so they've got virtual machines, web servers, powerful virtual machines. Everything starts at $2 a month. It goes up. You can get Xeon-based machines. You can get Epic, Xeon, AMD Epic machines. You can get your own full-blown 2-core. You operate it. You have exclusive use to it. Pick an operating system. They'll install it for you. And they'll rack it. They'll give you public IP addresses. And all you do is pay them a little money every month. And you will have, you know, it's not a web hosting thing, though they do have web hosting as well and some other incredible products. So dartnode.com. Go check them out and see what the goodies is. Now, here's the amazing cool thing. I just got a note from one of the guys there, and they said they are offering for viewers of ADRAMADA and other, you know, if you're associated with me through one of my platforms, this offer will apply to you. They are, let me get it. Oh, but there's a Valentine's Day sale, first of all, for everybody. 20% off first month of whatever service you get. Go to their landing page. You'll see the discount code. It's 2025-LOVE because it's February, Valentine's Day. That sale ends February 28th of this month, right? 2025 at 6 p.m. Central Time. Okay, here we go. We're also happy to provide any member of your audience or community with $24 of free VM credits. That basically means if you get one of their $2 VMs, it's free for a year. You can just experiment with that. You'll have a public IP address. You'll have your own virtual machine. Set up a web server on it. You can set up FTP servers. You can set up all kinds of goodies. How freaking cool. So if you want to take advantage of that software offer, contact me, because the first person who does that is what's going to trigger their process in creating a special link for our audience. Okay, so contact me first. After that first person is done and set up, then you'll be able to, everybody else will be able to do it directly. But if you're interested in a free virtual machine for a year, hosted at a data center with a real, honest-to-goodness public IP address, they'll give you $24 credit for a $2 a month VM. Wow. If I didn't already have amazingly cool stuff going on over there, I would be so taking advantage of that. Oh, how badly did I screw that up? Not too badly. Okay. Good. I am rethinking a little bit of the show format. I'm going to still do the regular one tonight, but it dawned on me. I've got a 6 or 7 year track record of shows on YouTube and other platforms, and it dawned on me, if you go back to one of my 7-year-old shows, the tech stuff is fairly current, and it's going to be for some years to come. But if I do tech news, and if I did tech news back then, He's 7 years out of date. And so, I'm hoping that this stuff lives in archive long enough that somebody goes back and says, hey, I want to talk about classful addressing, or part 2 of a 4-part subnetting series. And I don't want to suffer through multi-year-old tech news that's no longer valid. So I'm rethinking about 1/3 of the show and see if I can find something else to put in there. Love to hear your guys' suggestions. What would you see me killing 15 minutes in the show? What are you doing? Oh, goodness gracious. Okay, we have to stop that and then restart it. Okay. Well, that being the case, let's do some news. Techie news for the week. There's some cool stuff going on. Crew 9, right? We all know they went up last year for an 8-day mission, and it turned into kind of a Gilligan's Island spectacle. They have been up there 8 months now. Butch and Suni are part of Crew 9. Because of problems with their vehicle, it wasn't considered prudent for them to come back in the vehicle they went up in, so they brought it back, and they brought it back safely. Probably would have been fine, but better they decided to err on the side of caution. Well, then we were going to bring them back. They were going to bring them back in February. Oh, that's not going to work out. Late March, early April has been the target up until yesterday's announcement. Yesterday's announcement says Musk is going to have a boat ready a little sooner, 3 weeks maybe sooner. They're going to take Crew 10 up there, and they're going to bring back Butch and Suni hopefully about 3 weeks earlier. So now they were most recently scheduled for end of March, first week of April. Now they're going to send a crew up, Crew 10, on March 12th. Takes a day or two for them to get to the boat. They're going to do a 3-day handoff. So 12th, 13th, 14th, 15th. March 16th might be a good launch date for them. And coming down, that's about a 10 or 12 hour journey. And it's as long as it used to take me to get to my son's school to visit him or pick him up. Connects. Dark matter. I like the science of dark matter. I don't understand it. In fact, nobody does. We don't know what dark matter is. It can't be detected directly. Only indirect measurements are possible. And we've never measured it. We've never found it. It's never been detected on Earth, directly or indirectly. We think it exists because cosmologists and astrophysicists believe that there is too much gravity in the universe to be explained by the known quantity of baryonic matter, the physical matter that we can touch. It makes up stars and planets and dust and everything that's tangible. So the Brits have developed a new sensor that they believe would be able to detect the influence of dark matter. And of course, they've been using that here on Earth. There's been some other sensors here on Earth, but nobody's tripped the sensors yet. So it's a pair of levitating sheets of graphite. And in order to get them to levitate, they've got to be in microgravity. And they look for tiny anomalies that could point to the nature of this elusive substance. Okay. They're going to put it in orbit for 2 years. It's going up on the Jovian 1 mission, which is slated for 2026. It will be included in a little shoebox size payload package, and it will be ejected from the package, so it'll stay in its own orbit after the Jovian satellite either comes down or goes off and does another thing. So that's interesting space science for me. Here's one of my favorite subtopics in the world. You guys have known this before. More unsettled science. Ancient Roman concrete was used to make extremely strong structures, from buildings to the aqueduct 2,000 years ago. Some of it's still working. Some of it's still there and intact, and could carry water in sections of the aqueduct. There are buildings that are still up, whole buildings, major pieces of buildings. So it's really, really strong. And scientists, material scientists, love this stuff because they have been for decades trying to figure out what makes this concrete so good and so strong. And every now and again, somebody comes up with the answer, and it's settled science. And then, I don't know, every probably 3-4 years, you hear, oh, wait a minute, but wait, there's more. So this week, there's more. And I like this stuff. They are now they're not saying anything that's been figured out in the past was wrong. They're saying that anything that's been figured out in the last at least handful of revelations is incomplete. There's stuff that's missing. And right now, 2 new additions kind of sort of to the theory of why it's so strong. One, they think that the mix, there's some special stuff in there. There's some volcanic ash in there, and there's slaked lime and blah, blah, blah. Anyways, they don't think this stuff was mixed at ambient temperature. They think it was mixed at very high temperature. And that caused, a very strong mix, stronger than something that would achieve it at room temperature. And second of all, it caused some of the slaked lime to come out of solution and they didn't use the word crystallize, but make little tiny chunks of this form of lime mixed throughout this concrete. And what they're thinking is, besides the new super strong formula because of the high heat mixing, that it's still like any other concrete, though stronger, it will develop internal cracks over time. And they're thinking that these cracks develop a little ways and then they run into one of these lime chunks and the cracks stop. They can't spread any further through a homogeneous concrete. So, material science. All settled, right? No, there's still more questions. Nomad, NOM4D, pronounced Nomad, is a DARPA project. There's a lot of development going on in commercial, educational, government, and military circles to push the progress of space habitation and lunar habitation. Lunar habitation is a launch platform later for perhaps Martian habitation. And one of the big problems with any of these projects is, you've probably seen my picture on the Discord server, how big the ISS is. You know how many rockets they had to do to take up all the pieces to make those? Those pieces are huge. They do not lend themselves well to being manufactured or assembled in a space environment. And so it's unbelievably expensive, right? On $4 million a pound to send something up. So all of these projects are working on methods to lighten the load and be able to construct large structures in orbit, in space, on the moon. And so Nomad is the team that, the government team, the defense team that's working on that. And they're going to launch a new orbiting construction. During this orbital experiment, they're going to make a 1.4 meter diameter circular truss and assemble it in space. This is the first time they're taking their work of any kind of scale into space. It'll probably involve some human self-construction, but the goal is to be able to put pieces in space with some kind of automated process, maybe micro robots, maybe snap-togethers, I don't know. But this is a piece of construction that they're going to do in orbit to make a fairly good-sized chunk. So they're using very lightweight materials, and it's a nice big test. I'm really kind of enjoying watching this one. Meantime, University of Illinois in Urbana-Champaign, in collaboration with Voyager Space, will test a high-precision in-space composite forming process on a NASA commercial resupply mission in April of 26. Lots of other people working on this. This is interesting, and it doesn't seem like it on the surface. We had 3 sentences on this. Fedora 2025, this year, have incorporated AI integration into the operating system. A couple other goodies, some Wayland advancements, and some HDR, high definition, that other thing, and more. But what I like about this is Fedora is not the first to integrate AI. And you guys know my opinion on AI. I don't love it, but it's a fact, and so be it. So be it. Live with it. Rush. So they're not the first, but they are the biggest to do this so far, and I think that this is a harbinger for what we'll probably see in many mainstream distros, and it's not impossible, my opinion, and I haven't seen anybody write this, but I can envision Linus Torvalds potentially embracing this and not just integrating it, but making it part of the Linux kernel, which is what he does in the grand scheme of things. How about one more slide? This isn't news. This is just fun for me. Yeah. So, a little under a year ago, on February 26th of last year, I set up a pre-search node. It's a search engine, distributed search engine node that has been running nonstop on top of my desk, except during power failures around here. Comes right back up when the power comes back. So he's been running for just under a year and is served about 3,000 search requests. I don't know if that's a high number or a low number or what, but I just thought it was interesting. I probably should have waited for 2 more weeks at the anniversary of its thing. It'll be 2 days before the last show of February, but I just think it's interesting. So I put it up. Transition. Go back to Dave's head. No, don't do that. Very good. All right. Anything else going on here? Discords and upcoming gigs. Okay. Project is the next thing. Let's see what you guys are talking about. Ooh, there hasn't been much. The Dart node needs a bassist knock guy. You know a guy. Sweet. You know, there's always opportunity. These are idea people. They come up with ideas. They have something that we used to do back in my old company. We'd have a board of, wouldn't it be cool? Or cause it's cool. And we just put up on the board ideas, projects that we'd like to do if there was such a thing as having free time. It used to be a lot more free time in the early days when I got there, and we just, hey, here's a cool thing. Let's try it and see if it's worth incorporating into a video or a class or an article or whatever. Times change, but these guys still do that. And they are busy. They don't have a lot of time to do some of their cool ideas, too. But it's old. Good. All right, we'll talk. Yeah, contact me any of the usual methods. Wait, what? Yeah, it's $2 a month, Joey, for their minimal VM product. And if you contact me, they will give you $24 in credits. So you can apply that to this $2 a month and have a free VM for a year, a Linux VM or whatever. Check out their web server, dartnode.com, and get some ideas. Yes, you did hear that right. Your ears is really working today. Please like the video. I love Jethro Tull. Aqueduct, huh? Whoa, Aqueduct. The missus and I saw Ian Anderson 2 years ago doing nothing but Jethro Tull songs with a. It was just. I'm still quaking. And he did the minstrel leg up thing. I've got an idea for you. Since the great Mike Stromy went and retired on me during my project proposal. Cool. I'm always up to try something fun. All right, well, that takes us right on schedule to 7:30. So let us move on to Uncle Projecto. This is phase 2, step 2 of subnet masking. And we're not subnet masking, we're laying down the second part of the foundation necessary to be good subnet maskers. And it's not two legs of two foundations. It's last week we did binary decimal conversion back and forth, and now we're extending on that to talk about IP addresses and the first generation of how we use them in an organized addressing approach, which we call classful addressing. And why we call it that will make sense as we go on. So this presentation is about classful addressing. And by the way, if I got a couple of Network Plus classes going on. This is where you should be taking notes. I had about 15 minutes to do 0 through all of subnetting with these classes because of the material that I'm using. So I'm recommending to my students, check this thing out. I have a lot more time and I can explain things a lot more fully this way, and you will get it. All right, so this presentation is about classful addressing. It does not include subnets or anything beyond the default subnet mask. Now, we're using a term here without explaining it. Sometimes you have to do that, and we'll get around that. We will tackle subnets, subnet masks, and wax in this lecture and in the upcoming next two. So, a short explanation to get us started. So I'm going to stay on this slide here, and I'm just going to do talking head here for a moment. So IPv4. There was an IP version 1 and a version 2 and a version 3. We've been on IPv4 for 35 years, something like that. Our 32-bit binary numbers. That's it. Your computer has an IP address, and all it is 32 bits. And when I communicate with you, or when my computer communicates with your computer, he's got a destination address of your 32 bits and my source address of my 32 bits. And that's just something that we humans can't comprehend. So we break them up into 4 8-bit chunks, and we call each of those chunks an octet. Makes it easier for humans to relate to them. We separate each of those octets when we write them down in decimal format with a dot. So number, dot, number, dot, number, dot, number. Each number has the theoretical potential to be anywhere from 0 to 255. So 192.168.1.100. There's a decimalized version of 32 bits. And when we use decimal versions, decimal numbers, and separated them with dots, we call that dotted decimal notation. Yeah, that kind of makes sense. Slide 15, moving up and onward. Let's move this over here so I can advance slides without losing track of stuff. There we go. Last week's slides were all black and white. This week's slides are all green and white. And by the way, if you ever want a copy of all these slides, oh, and I fixed that one last week that had the typo in it. That's all operational. You know, when I make these slides, I look them over at the end, and I made about 5 slides and realized I totally blew all 5 of them. I had to restart them. What a pain, huh? So, an 8-bit octet is a base 2 number using 1s and 0s. I just filled out the 4th octet here. We could pretend there's a bunch of 0s and a bunch of 1s in the other 3 octets. Any given octet can have, theoretically, 8 bits that are all 0, 8 bits that are all 1, or any combination of 1s and 0s. There's 255 possible combinations between 0, 0, 0, 0, 0, 0, 0, 0, and 1, 1, 1, 1, 1, 1, 1, 1. So again, we like to think about those in decimal formats, and you can convert those the way we learned in the last show. So each of these octets has their own set of 8 value columns. Working left to right, we start with the 128ths column, and then half of that, 64, and half of that, 32, and half of that, 16, and 8, and 4, and 2, and 1. And we do that for each of the 4 octets, and that's what gives us the ability to make 4 numbers whose range is all between 8 zeros and 8 ones. If we had worked directly with a 32-bit number and converted to decimal, we could do that. But there would be 4 billion numbers. What's your IP address? 2,759,000,000, you know? So maybe not. So an IP address is a unique set of these 4 numbers made up of 32 bits, and some of those numbers are assigned as the network address, and some of those are assigned to the host address. But whether or not we sub-assign these things or wholly assign them, there is a unique 32-bit number that belongs to every computer on the internet, every printer on the internet, every server on the internet, every router, every device that is network addressable. So here is a real example. I just decimalized it. I didn't want to put down all the binary values in here. So here's some device. He has an IP address of 187 decimal or dot 42. We're doing all this in decimal dot 202 dot 149. So this is dotted decimal notation. 4 octets expressed in decimal values, and each of those decimal values separated from the others by a dot. Fair enough. And now we're going to jump away and we're going to introduce this term that I threw out and didn't define a little bit ago, the subnet mask. When a device gets an IP address, he has to have, or it won't work. The IP address we give him will not work unless it is also accompanied by this mystical, magical thing called a subnet mask. The subnet mask is a 32-bit number that's internal to a computer. It never leaves the computer. Nobody outside of that computer, no other host outside of that computer, will know that computer's subnet mask value. And that computer will never know any other computer's subnet mask value. It's used internally for an internal calculation. So the subnet mask is something that's completely internal to each host, never leaves the host. Our host computer will know his own subnet mask, but will never know the subnet mask of another host, and no other host will ever know our subnet mask. So what is it? Well, that'll take a second. It's a number. It looks like it's an IP address, except for our purposes, there are only 3, and it's a set of ones and zeros that always starts as a contiguous string of ones from the leftmost octet in the leftmost position. So if we express this top line in binary, it's 1111, 1111, followed by 24 zeros. That makes up 32 bits, right? If we express that in dotted decimal notation, it's 255.0.0.0. We give this thing a shortcut name. We count how many ones there are. There are 8 ones in this top line. And so we call the subnet mask in there a WAC 8. / is a WAC. So it's a WAC 8 subnet mask or a WAC 8 mask. That's one possible subnet mask in classful addressing, today's focus. The next possible subnet mask is 16 contiguous ones starting from the left, followed by 16 contiguous zeros. If we express that in dotted decimal, 255.255.0.0, there are 16 contiguous ones in here, so we shortcut calling it 255.255.0.0 to simply calling it a whack 16 subnet mask. That's a classful subnet mask, and the last of the classful subnet masks follows the pattern here. A string of contiguous ones that occupies the first 3 octets. 8 ones, 8 ones, 8 ones, 8 zeros. So if we express that in dotted decimal notation, 255.255.255.0, there's 24 contiguous ones working from the left, and so that's a whack 24 mask. That's pretty simple. Now, let's stay on this page for a second, because we still haven't answered the question that I asked 2 slides ago. What is it? We know some things about it. It never leaves our system. We know that it's an internal tool that's used for doing some calculations, and we know that there's only 3 of them available in classful addressing. Why that is, that's going to take another show. So the role of the subnet mask is very simple. Subnet masks are strings of ones that tell us which bits of an IP address are network address values and which bits are host values. So whenever a host gets an IP, now I'm going to show you how to do that, of course. Whenever a host gets an IP address, no matter how he gets it, dynamically from a DHCP server or statically because some human typed it in manually, it has to get a subnet mask. Your operating system might apply a default subnet mask based on the numbers that based on the IP address that you have. Or you can override that as an administrator or a user, or some operating systems don't auto-supply a mask. In Linux, you have to manually type in a subnet mask, and that means you got to know the rules of subnet masks, and we will. Change, check with there. Okay. New slide. This looks kind of the same as the previous slide, but not so much. So what we're doing now is we're going back to that example IP address that we had a few slides back, 187.42.202.149. And whatever computer this IP address is in has a subnet mask inside of it of 255.255.0.0. 16 contiguous ones, so this is a whack 16 subnet mask. The job of the subnet mask is to determine which octets are network addresses, and everything that's not a network address is the host address on that network. So here's the shortcut. Every place that there's a 255 in the subnet mask, those octets are the network address. So I've got 255s in my first 2 octets. That means the first 2 octets of my IP address are the network address that I'm on. I'm on network 187.42.0.0. Network addresses always have .zeros after the address values. And on network 187.42.0.0, I am host 202.149. So this whole thing is my IP address, but some of these octets define what network I'm on. Some of them are my host address on that network. 2 important facts. I know they're important because I wrote them down and I said 2 important facts. All hosts on the same network must have the same network address. So if I'm connected to a switch and 10 other computers, 20 other computers, 50 other computers are on that switch, in order to communicate with each other, we all have to have the same network address components in our IP address. So I've got 187.42. My router's got an interface that starts with 187.42. Fred has 187.42. Sam and Sally have 187.42 at the beginning of their IP addresses, and we all have to have unique host bits so that we don't conflict with each other. I can't be 187.42.202.49, and Pat is also 187.42.202.149. We will conflict, and nothing good will come out of that. Can even crash the entire network. That's happened to me, and I talked about it one day back in the days of drama. So let's say somebody screws up. They typo it wrong. They make it 187.41. Something. They won't be able to communicate with anybody else on our network. And it's because of the subnet mask. So that's what we're going to try to get into. That's our fact number 2, or part of fact 1. So every host on the network has to have unique host bits, but they all have to have the same network bits. Anything else here? Okay. So we're going to use the subnet mask to figure out what network we're on. That is the first role of a subnet mask, and we did that. We look at the mask and we find out which octets have 255s, and that tells us which octets of our IP address are our network addresses, our network bits. Well, that's fine, but big deal. The only reason that I care about what network I'm on is because I want to talk to other hosts. And some hosts that I want to talk to might be on the same network as me, or they might not. So here's the second and final job of the subnet mask. The subnet mask has 2 jobs. Check which octets are network bits in my computer, and check which octets are network bits in a destination computer. So we got a little example here. I've got a host. It's me, host A. It has an IP address of 192.168.1.100. It has a subnet mask of 255.255.255.0. So there's 3 contiguous sets of 8 ones. There's 24 ones to make up 255.255.255. And so we shortcut that name to WAC24. The host that I want to talk to has the IP address of 192.168.1.173. I don't know what its subnet mask is, and I don't care. And it doesn't care what my subnet mask is. So I'm going to use my subnet mask before I ever send a message out to that station. Maybe it's a internal web server. And I'm going to use my mask, and I'm going to look at my network address through the lens of my subnet mask. My subnet mask says the first 3 octets have 255s over them. Therefore, my first 3 octets are my network address. So looking at the top line, my network address is the first 3 octets of my whole IP address, 192.168.1. Cool. I know what network I'm on. Now I'm going to use the subnet mask and look at the destination IP address and find out what network it's on. So same subnet mask. My mask says check the first 3 octets. Those where the 255s are. So host B's first 3 octets are 192.168.1 into the text here. Host A looks at the destination, and we did that. First 3 octets. And the 2 network addresses are compared, and they match. I'm on 192.168.1. Host B is on 192.168.1. We're on the same network. And now that I have that information, I know how to talk to this station. If he's on the same network that I am, I can communicate directly with him. I can simply send out an IP packet on the current cable. It doesn't have to go to the router. It just has that host's IP address, 192.168.1.173 from 192.168.1.100. Please get me index.html. Give me your landing page. So that's the goal of subnet mask. I use that to look at my network bits. I look at the destination recipient that I have in mind's network bits to find out if he's on the same network as me. And if he is, I can communicate directly with him without using a router, the services of a router. But slide 20. What if the destination network address is foreign? It's not my local LAN address. So new scenario. Host A has successfully saved a file to host B. It was a file server, I guess, instead of a web server. Fine. Now we need to check an internal web server that we're going to call host C. The web server is at a URL, www.coolplace.com. And we did a DNS lookup, happened magically and in the background, and learned that its IP address is 113.200.77.50. I'm still host A. I'm still got an IP address of 192.168.1.100. My subnet mask doesn't change. It's still 255.255.255. There's 24 ones to pull that off, so it's a whack 24. And now I'm going to use the subnet mask to find out if host A and host C are on the same network. So previous example, I got 255s over the first 3 octets. Host A looks at his own first 3 octets and says, I'm on network 192.168.1. Then he uses that mask and looks at the first 3 octets of the destination IP address. So the first 3 octets of that are 113.200.77. That's not a match. That tells me, host A, that that host is not on the same network as me. And because I'm not a router, I can't deliver that thing directly. So I'm going to make a packet for it. I'm going to have a destination IP address at the beginning of that packet that says 113.200.77.50 from 192.168.1.100. But what I'm going to do is I'm going to hand that packet off to my default router, my default gateway. And the default router will look at that and say, I see what you're trying to do here. You want this message to go to network address 113. Blah, 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 blah. I'll see if I'm directly connected to it. Maybe one of my interfaces is, and if so, I'll hand it straight off to the recipient. And if not, I'll hand it off to some router that may be connected or may lead to the destination. So that is the role of the subnet mask. It looks at my internal IP address and figures out which bits are the network address, and then it looks at the same octets, the same number of octets for a destination IP address, compares them. If they're a match, then they're on the same network, and the source can deliver to the destination directly. And if there's no match, then we have to hand it off to a router for handling. Now it gets fun. So in classful subnetting, there are only 3 possible masks. 255.000, a whack 8, 255.255.00, a whack 16, and 255.0, a whack 24. Any other value, a whack 25, a whack 17, a whack 11. That's, oops, I didn't know you could do that. That's, oh man, it just, now I know what you can and can't do and shouldn't do. Okay, I did that. We're on slide 21. That is not going in order. I've got to go and start it over again here and get to 21. Blah, 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 blah. Out of 24. 8, 9, 10. I got 6 minutes. I'm going to make it. 12. Oh, I see. Okay. So we've got 32-bit IP addresses. And the elders of the internet, back when they came up with this scheme, said, we need an organized fashion of handing these things out. And so they decided to chunkify them into 3 different sizes of chunks. And they called these 3 chunk sizes classes. There's a class A, a class B, and a class C. That's why we're going to call this classful network addressing. And this slide has a ton of information in here. So I'm just going to talk about this slide right now. A class A network is any network. You identify what class of network it is by looking at the value of the first octet. So if the first octet falls between 1 and 126, it's a Class A network. Class A networks have a default subnet mask of 255.0.0.0, WAC 8. So that means the first octet not only tells me if this is a Class A, but the first octet is the network address. That's a coincidence. That's not going to happen in our other examples. So there are theoretically 126 possible Class A networks. And each of them has 24 bits left over for node bits. That's about 16, almost 17 million hosts. So who got these addresses? Because they're gone. They were all assigned the week after they were invented. It's the operators of the internet and the tier 1 internet service providers. AT&T's got one, and Verizon has one, and IBM has one, and the U.S. government has one, and the military has one, and some other really big companies. If the value of the first octet falls between 128 and 191, it's called a Class B network. And Class B networks use the first 2 octets as their network addresses. So the mask is 255.255, it's a WAC 16. And what that means is there's a network out there, there's a Class B network called 128.0, and another one called 128.1. 128.2, 128.10, 128.50, and so on and so on until we get to 128.255. And then we increment 129.0, 129.1, .10, .40, and we keep doing that until we get from 191.0 through 191.255. So they all use the first 2 octets as their network bits, because the default subnet mask of a Class B network is WAC 16, and Class B networks are identified by the value of the first octet falling between 128 and 191. So if you crunch the numbers on that, there's 2 to the 16th there's 16,000 possible networks, and each network's got 16 leftover bits, the last 2 octets for node bits. That's 65,000 hosts per network. And then our last class of network is Class C networks, identified by the value of the first octet. I know I'm going to run out of time here in about a minute, so I'll finish up with this slide, and I'm going to do example slides next week to start the show, and you can practice these things. But again, contact me on Discord or by email if you want these slides in advance and you want to do practice before next week. Happy to get them to you. Okay, so the default subnet mask of a Class C network is 255.255.255.0. It's a WAC 24. That means the first 3 octets of a Class C network are its network addresses. There's about 2 million Class C networks, and they each have the last octet to use for node bits. Okay, that's going to wind up this show. We will extend a little bit next week. Let me make a little note here on how far we got. Yeah. So next week we do special addresses, which are cool, and then we do practice. There's only a handful of slides left. About 5. All right, well, kids, that is most of step 2. We can ignore special addresses, but I think they're kind of important in here. And then there's 3 practice exercises. Let me see what you've been talking about whilst I finish this, close things up. Let's see, got an idea? Okay, isn't the WAC24 the most common subnet mask? It is the most common subnet mask for a Class C network because it is the default subnet mask for a Class C network, and most Class C networks are, if you're buying a store-bought router, 192.168.1. That's a Class C. We use those first 3 octets because it's a WAC24 to define the network. Oh, don't say such nice things. It's the easiest mask to use. That's not true. It's the one you're most used to. Once you understand all these principles, working with any other is really easy. If you've got a Class A network, let's make it a private network, a 10 dot at your house, the normal default subnet mask for a Class A network is WAC 8, first octet. Nobody uses a WAC 8 on a Class A network. They either use a WAC 16 or a WAC 24 and make a bazillion subnets. That's next week. But it is all pretty easy stuff. No. It's no problem, Shia. It's on Archiver. We'll be in 2 minutes. All right. Well, I'm going to wind this up then. It has been as fun as always. I hope you've had as much fun as I have. And we will do this again a week and a day from now. Quick reminder, dartnode.com, our sponsor. They have a Valentine's sale. They've got basic VPSs starting at $2 a month. And if you contact me, first person to contact me, we will use them as a template to set up for everybody else who contacts me. But if you are associated with ADRAMADA or any of the other platforms that I'm on, Dartnode will give you $24 in credit toward your own VPS, which is $2 a month. So you're going to get a free VPS with a public IP address for a year. And that is some pretty doggone cool stuff. You want to buy their regular stuff, they got a Valentine's Day sale going on until February 28th, 6 p.m. Central Time, 20% off the first month, any of their products. Okay, so as ever and always, I wish you a great rest of the week. Take care of each other. Take serious steps to stay healthy. And if at all possible, call or visit your parents. And never forget, technology is great, but the greatest resource we have are, of course, you and I. And with that, I bid you good night. I will see you on ADRAMADA next week. Friday looks like, and the other platforms that I'm on. Until then, remember, how you do anything is how you do everything. Eat up or